Welcome to 2021 question B1. So the image on the right shows a pedestrian bridge in Newport, Wales. It is based on a parabola. Okay, so it's linked to Conics and an orthographic projection question. So the figure B1 shows an elevation plan and end view of the model of the bridge. Okay, so our elevation plan and end view. The curve ABC is a parabola with vertex B. So ABC, right, and ABC here, that is a parabola. So we're going to need to use our parabola construction to create that. A pictorial view of the bridge is also shown, so our pictorial view. Draw the given elevation and end view of the bridge. So our elevation here and our end view there. Okay, so we'll get started with that. First off, I'll draw my XY line. So from here, I'll measure my horizontal measurements first of all. So I got 20 and 190 and another 20. And my vertical measurements, I've got 50 and 70, which is 85. Okay, I'm going to start off with my parabola ABC. Okay, so that point there is going to be A, and then C is over here, and I'll find my B. So if it's 190, half of that then is going to give us the position of B. So right, that's going to be A, C, half of 190 is 85 or 95. Yeah, so 95. And that's going to give me B. Now, to make life a little bit easier for me, I can see that there's these divisions that need to be done with this parabola. And so just to find those points exactly, I'm going to do it, or I'm going to divide up my rectangular shape that contains the parabola into those divisions. So we've got 1, 2, 3, 4, 5, 6, 7 divisions. So draw a line at any angle from B, step out 7 times. A good habit always is to index those so we know I've stepped out the correct amount. 7 divisions, 1, 2, 3, yeah. And I'm going to join that back to the end of my line. And draw parallel lines from there. So drop those down vertically. So there are vertical divisions. Right, and now I need to divide up this side into 7 also. So line at any angle again. Step off 7 times. 1, 5, 6, 7. Okay, and these ones on the side, then we join them up to the vertex. Okay, so where 1 meets 1, 2, 2, 3, 4, 5, 6, and 7. Okay, so that is going to be my free end curve for the parabola. And then we'll mirror that across, or use axial symmetry to bring that across to the opposite side. So project it across perpendicular to my axis. And equal distances on either side of that axis. I've got my free end curve on this side. Okay, and then looking back here, we've got our little stand that our bridge is on top of. Oh, I forgot to measure my 10 and 10 just out front A and C. Solid line along the base also. And lastly then, our vertical members there, they're not vertical, they're actually sloping in. They appear as vertical members in elevation. Cables. And then at each one of those points, bring them down also. Okay, so that's my elevation drawn, and they also want us to draw the end view. So just project out here any heights I have to begin with. We'll look at our elevation or end elevation. Okay, so 80 in length, 70, and then we're going to have some heights to project over. I think it's every second one of those members, right, that we're going to have appearing here. So those are in line with each other. 1, 2, those are in line with each other. 1, 2, those. Okay, so from over here, doesn't really matter how far, I'm coming about 20, and we'll draw our 80 depth, our 70 degrees, so line up my bullseye and go 70 and 70 degrees. Okay, so it'll be contained within that, and yeah, so we'll start filling those heights and those members coming across. So every second one, as we said. That's the top and the bottom of my base, and then 1, 2 up to this one. 1, 2. Okay, go heavy over that. I should have done that to begin with. Okay, so that's my elevation and end view of the bridge. Okay, and effectively this point here is AC, and up here, so AC there, and B is that top point. Alright, so now they want us to project to the plan. So my widths between elevation and plan, or length, sorry, this way, will stay the same, and then I'll be projecting back at 45 degrees for my depth. So let's start with I suppose the supports for the bridge. Bring these down also. Back to the supports. Check then across. So that's the outline of those supports, and we also have these surfaces on the top that I've brought down. The width or the depth of them there, so project them down here also in the elevation. So I have the top surface in here. Okay, and we won't forget about joining them back to the base. Okay, so next up we want to find the, I suppose, the parabolic curve. Okay, we could go to the trouble of redrawing all of this again with our construction, but just to save time we can actually use what we have. So I've got points, so for example this point here it is in my end elevation. I can project that down and around and find the corresponding point. I'll be able to draw my feeling curve. Okay. And then that would be symmetrical then on this side, but we can also project it down from the opposite side. So let's go with those necessary points. Project down their width first of all, their depth. Back at 45 degrees. I suppose I shouldn't forget the very top there, and by B at the very top also. Check them back at 45 also. Okay, so I'll start with finding B and the corresponding point at the back. So that. So this is A, B, and that's C. So this parabola, start with it, so we'll follow these points 1 and 2. It's at these in this position, so I'll bring it down, follow it around, and drop. Both of those down, so there and there. Actually, to save time, I'll find it in the back also, so there and there. Alright, and we'll just repeat that process then for each of these points. So let's see, project down this one and corresponding on the opposite side. This is going to be a bit repetitive as we go along. So here, and 2 there, and 1, 2 there. Alright, and on to the next one. So there you have it. Drop down this side. I'll find this one, then this one, and down. So, there and there. There and there. Okay, and I think that's all the points I need, so I can draw my grand curve here. Parabola. And the same on the opposite side. And then we won't forget about these lines also looking down on top of it. So that. Oh, I nearly forgot. Need my solid lines there to show the width of the road on this bridge, and also all these members that we talked about repeating along, and every second one is going to go right the way through. So I can direct those down. Show my starting end point for the width of the bridge. Okay, so first one's there, second one is going to go right the way through. Heavy to curve. So like this particular question is a bit repetitive at times, but here's a nice one to skip one. In essence, you could really say a junior student could complete this question if they knew how to draw a parabola and they knew the orthographic views. They could definitely do the first part A and part B of this. Okay, so I would say that is my elevation plan and view completed. Just double check that I've got everything, all the heavy lines, all the light lines matching up. Yep, that's all good. So finally then, determine the true shape of curve ABC. So curve ABC, so here we have an edge view of ABC. We've got it labelled there. So we have two methods of doing this. I could, I suppose, project out perpendicular to our edge view creating an x1, y1, so that would be an auxiliary plan would be drawn. But I don't think that would fit on the sheet and it might create a bit of confusion. So simplest thing to do would actually do rotate. Okay. As we look at this edge view, this point here is a point view of line AC. Okay, so it's a point view of this line here. So we're going to rotate everything down until it's on a horizontal plane, and we'll be able to see it like that. Okay, so when I look down on my plan view, that is going to give me a true shape of the parabola ABC down here. Okay, that we actually just thought of a third way. Because we have the true length of the height of this parabola, we could actually redraw the box. So give it that distance would be the same as here. And we have the true length stepped off, and you could actually redraw it, but that would probably take a bit too much time. So we'll do it the quick way. So I'm going to rotate down to this position, all those points. And they're only looking for the curve ABC, so I only need to rotate B, and we'll use those couple of points that we used down here to create the curve. So I won't use every single one, just would take too much time. So I'll just use the ones that we use for the plan view. So rotate everything down. Okay, so we go over here. Just rotate it into this position. Okay, or bring those down. So everything will rotate it. Here, and now we're looking down on top of that in plan. It's a true shape. So drop everything down. Back to 45 degrees. Right, let's look at B first of all. We'll rotate B and have, so B is going to be there, so that's my B. And then we'll step out to each one of these points as we go down along. So okay, so now with my points, I can draw my freehand curve, which is a true shape of parabola ABC. Okay, so that is true shape of curve ABC found. Okay, probably the quickest method of doing that, the rotation method.